Hi guys. We were talking about exponential growth when we left school last week, so I just wanted to continue that conversation and apply it to what's going on with the spread of this virus here, um, and kind of show you the point in this spread that we're going to be looking forward to. So what they're saying right now is that the number of new cases doubles every 6 days. So I'm not going to use real numbers for the number of cases because I don't have those memorized. And so I just want to simplify things and just say that on day 0 that there was one case. So I'm going to put a dot there at one case. And then every 6 days, the number doubles. So this one case after 6 days becomes 2 cases. And after 6 more days, or here's 12 days later, almost 2 weeks later, there's only 4 cases. So you in your homes right now that you're socially distant, you're distancing yourself socially right now, you might be saying to yourself, well, I don't even know anyone who has the virus. So I'll say yet, because you're actually playing an important role right now by being away from people, and we'll talk about that in a little bit. Let's continue this so you can see what happens as this continues to grow exponentially. So 2, 4. Now 6 days later, those 4 people become 8 people, and then 16 people, and then 32 people, and then 64 people, and then 128, 256, 256, 512, and now you can see there's some significant movement in the growth pattern of this virus. So that's 512, and then at 60 days, so here's about 2 months, we're at 1024, right about there. And then just after that, 6 days later, this went from 1 to 2. 6 days later here changes from 1024 to 2048. So in 6 days, in a week time, this changed by 1,000, a little more than 1,000, and in 6 days, this only changed by 1. So that's the exponential growth that this virus is going through right now. We're in the early stages, and so some smart mathematicians, doctors, scientists, they're telling us stay away from people because here's what's coming. And I'm sure you've seen these graphs in some way or another. So what we want to do by remaining socially distant is it's going to spread, but we want to slow it down. And the reason is because hospitals only have a certain number of beds for people that run into trouble. So right now, we're not at full proactive measures. We're not quarantined to our homes totally. We can get to stores and things like that. But we're probably somewhere in between these two. And what we're hoping for as this virus spreads is to stop this from happening, because these people who are sick, if it spreads quickly, won't have room in a hospital. Okay, so we're trying to keep the spread. It's going to spread, but keep it in here so that people that need hospital beds can get to the hospital on time. All right, so just want to continue along here. So here's what we're looking for. Eventually, as you saw in those previous graphs, eventually this exponential growth, number of new cases each day, it's going to hit a peak. And after it hits that peak, number of new cases each day, it's going to slow down, and eventually this virus will die out. This peak here is the day we're kind of looking for, because as that growth model, if we consider the total number of cases, here's where the exponential growth takes place. The rate of cases each day is increasing. Once it hits that peak, this is the day we're looking for. Once it hits that peak, the total number of cases is going to slow down each day. And so this is a logistic growth model. And I want to continue this conversation in a different video. And the new video would be for my calculus classes. We're going to solve a differential equation that models this logistic growth function. All right, guys. So stay strong. Just thinking of you, and be with your loved ones, but not too close.